Welcome back to the channel. In today's video, we will be showing you how to calculate the axial force and the moments for a column that needs be designed. Simple beam and column construction refers to a multi-story building structure with the following characteristics. The structure consists of beams and columns, where the beam end connections are assumed to be pinned. Lateral stability of the building is provided by masonry, or concrete cores, or vertical bracing. In other words, not bending of the columns. The beam reactions are assumed to act at a distance of 100 mm from the face of the column. The eccentricity is causing bending about the y-y axis of the column. The bending about the y-y axis of the column equals design beam reaction times eccentricity, where the eccentricity equals half the depth of the column plus 100 mm. For bending about the ZZ axis, the beam reaction is assumed to act 100 mm from the face of the column web, giving an eccentricity of half web thickness plus 100 mm. For internal columns, the design bending moment is taken as the difference between the two moments on each side of the column. This means that where the columns are positioned on an equally spaced grid, the moments on each side will usually cancel out, and the column is designed for only axial load. Let's take a simple example. We have a 203 by 203 by 52 kg per meter universal column which supports 4 beams. The design reaction force from each beam is as shown. So, how can we work out the axial force, and the moments for which the column must be designed? First, working out the design axial load, which is simply the sum of the loads. So, axial load equals 85, plus 220, plus 130, plus 65. This gives us a value of 500 kilonewtons. Next, to obtain the moments, we need the precise dimensions of the column. For 203 by 203 by 52 kg per meter, universal column, the depth of section equals 206.2 mm, and the web thickness is 7.9 mm. You can get these figures from Blue Book section properties. So, working in meters. The bending moment about y-axis equals 220 kilonewtons minus 65 kilonewtons times half of the column depth, which is 0.1031 meters, plus 0.1 meters, which is the distance from the face of the column, where the beam reaction is assumed to act. This results in a value of 31.5 kilonewtons meter. Finally, working out the bending moment about z-axis, which equals 130 minus 85 times half the web thickness, 0.004 meters, plus again, the distance from the face of the column, where the beam reaction is assumed to act, which is 0.1 meters. This corresponds to the value of 4.7 kilonewtons meter. Note: the beam moments at a particular floor level are divided between the upper and lower columns in proportion to the column stiffnesses. In other words, their moments of inertia divided by column heights values. So, for columns with the same cross-section and same story height, the moments are divided equally. Thanks for watching. We hope you found some useful tips. Check out our website at structuralengineercalcs.com. Please like and subscribe, and let us know what would you like to see next. The human footprint is a masterpiece of engineering and a work of art. Stay safe. Goodbye, and see you soon.